And today we'll move on to rational functions, reviewing rational functions. And we have the rational function has a variable in the denominator, and it has to have integer exponents, so no radicals. Something new, a new characteristic of these that we didn't see in the linear or the quadratics is that these have asymptotes. So why does it have a vertical asymptote? Let's look at a table to see why it would have a vertical asymptote. And we can see that as we get close to 0, so 0, and then we'll have 1 over 100, 1 over 10, 1 over 2, and 1. If x is 1, then we have 1 over 1. The y value is 1. But now we'll have 1 over 1/2, so that's 2. And now we'll have a 10, and then 100. What's happening as x goes to 0, the y values are going to infinity, and this is undefined if you divide by 0. So we can see that the y values are going to infinity, and that's why we see a vertical asymptote. Happens on the other side also. So, and then why is there a horizontal asymptote? We can look at the reason for that by choosing other x values. Let's choose these x values going out to the right. And if we're going to, the y is 1 over x, so that's 1 over 1. This will be a 1 over 10, 1 over 100, 1 over 1,000. The further we go to the right, the closer we get to 0. So there's the horizontal asymptote. As you go out to the right, the graph approaches 0, and there's the horizontal asymptote. All right, we have some shortcut, a shortcut for finding horizontal asymptotes. Let's review that. So if we have this function, the horizontal asymptote is y equals 0. And I'll just do some examples and see if you remember the rule, and then I'll talk about the rule. Now it would also have a horizontal asymptote of y equals 0. And that has a horizontal asymptote of y equals 0. And this doesn't have a horizontal asymptote of y equals 0. It has a horizontal asymptote of 4. This has a horizontal asymptote of 1/2. So, if you don't remember the rule, here it is. We look for the degree of the numerator and denominator and compare them. So that's a 1 and a 2. We compare these. If the denominator is a higher degree, then it's automatically y equals 0. We compare the degrees. The denominator is higher, so we get 0. Compare the degrees. The denominator is higher. Here we compare the degrees, and they are equal, so the asymptote is going to be 8 over 2. Here we have equal degrees, so the asymptote will be 1 over 2. So those are the rules for horizontal asymptotes. So let's use a palette for this, y-intercept. So x and y-intercepts still do the same way. Make the x 0, and we get a 1. So we have the x-intercept, the y-intercept. The x-intercept is when the y equals 0. And if we multiplied both sides by the denominator, we'd have 0 equals 1. So there's no solution. But that just means there's no x-intercept. It doesn't mean there's no graph. Okay, horizontal asymptote. We could look at 1 over x plus 1 as 1x to the 0 over x to the 1. So now you can compare the degrees, and we have a higher degree in the denominator, so the horizontal asymptote is 0. Vertical asymptote is when the denominator, we just look at the denominator, and it's -1. But we also want to make sure that when we put a -1 in to the function, if I put a -1 there, we don't want 0 over 0. So we could say that f of -1 is not 0 over 0. If we do get 0 over 0, then it won't be a vertical asymptote. And then we'll just fill in the table for as many points as we need to draw the graph. And we have 0, 1. Y equals 0 is the horizontal asymptote. Vertical asymptote is at -1. And let's check what's happening over here at -2. So if we put a -2 in, we'll have 1 over -2 plus 1. That is -1. -2, -1. If we plot some more points, we'll see the graph doing this. And the domain is all the x values that have a point on the graph. So that's everything except for -1. And we'll go to -1 and exclude it. Excluding -1, go to infinity. We can do the same thing with the range. The range is excluding 0. So exclude 0 and go 0 to infinity. Okay, pause the video, do the same thing with that function. So the y-intercept will be -1. The x-intercept does not exist. Horizontal asymptote, we have x to 0 over x. Comparing the exponents, the denominator is greater, has a greater exponent, so it's y equals 0 for the asymptote, horizontal asymptote. Vertical asymptote is when the denominator equals 0. So the vertical asymptote is 1, and we don't get 0 over 0 if we plug that back in. Vertical asymptote, horizontal asymptote, 0, -1. If we plot some points, we'll see At 2, we go to 1. With a domain that excludes 1, negative infinity to 1, 1 to infinity, and a range that excludes 0. Okay, pause the video and try that one. So the y-intercept will be 0. The x-intercept is 0. Horizontal asymptote. Compare the exponents. They're equal, so we take the coefficients, and we have y equals 2. Vertical asymptote is when the denominator equals 0, so that's negative 1. Negative 1 will not have a value of 0 over 0, so that means it is a vertical asymptote. And graph. Vertical asymptote is at negative 1. Horizontal asymptote is at 2. And we have 1 point on the graph from the x and y intercepts. So we should get a couple more points. Let's try negative. Let's try negative 2 to see what's happening over here. And that'll give us negative 4 over negative 1. So we have positive 4. At negative 2, we go to positive 4. And if we plotted some more points, we would see this and this. The domain goes from negative infinity to negative 1, and then negative 1 to infinity. Range, negative infinity to 2, 2 to infinity. And then we just have to simplify some complex fractions. And there are two ways to do it. We could multiply numerator and denominator by x plus 1. Or we could get the common denominator up here and combine and then simplify. So why don't we just multiply numerator and denominator by x plus 1. So if we do that, we'll have x plus 1 over x plus 1, 3x plus 3, 3x plus 3. The denominator, we can just leave it as x minus 1, x plus 1. This will be a 1 plus 3 is 4. 3x plus 4 over x minus 1, x plus 1. Okay, and try that one. Pause the video. So we can just multiply by x plus 2. And that would give us 4x plus 8 minus, we'll put an x plus 2 up here, that'll be 1. And we have 4x plus 7 over that, and we'll stop there.